2019 question 8, statistics 45 marker. To go with 2 probability questions, given 95 out of 300, about a third of the exam. A motoring magazine collected data on cars on a particular stretch of road. Certain details on 800 cars were recorded. The ages of 800 cars were recorded, bit of repetition, and 174 of them were new. Well, the minute you see this, you're thinking to yourself, this is population proportion. 174 out of 800 were new. And as a decimal, this is going to give me 0.2175. Now, when we're setting up our interval, we're going to add something to 2175 and we're going to take it away. This is going to become my 95% confidence interval. So 1.96 by the square root of p times 1 minus p over n will give us this error here for my addition and subtraction. So 1.96, what I type into the calculator is the fraction 174 over 800 by what's left, 626 over 800 divided by 800. And actually what you're typing into your calculator here is the square root of 174 by 626 divided by 800 3 times, which is 800 cubed. And you're multiplying it by 1.96. So if we multiply this out, we're going to get 0.02858, 0.0285879, 5879. I'm just taking a few extras here. It's 4 significant figures. So we're going to need, if there's a 0 there, 5 of them. So we'll round the 7 to an 8 here. And we get rid of the 9. And we'll round off the 4 significant figures then at the end. So I have to add this to 0.2175. So I get 0.24608, 0.24608, 0.2461 on that side. And then on the other side, if I take it away, I'm going to get 0.188913, 0.1889 is enough for significant figures. So this is my 95% confidence interval. P, the proportion of new cars on the road is between these two figures, 18.89% and 24.61%. Nice easy start for this question. You obviously need to know this formula jumps into your mind. You've studied statistics just before going into the exam. The data on speeds this time of these 800 vehicles were normally distributed with an average of 87.3. So write down what you're given. Mu is equal to 87.3. So looking at z-scores here, standard deviation is going to be 12. What proportion of cars on this stretch of road would you expect to be fine traveling at over 95? So
thank you.
We're testing x or x bar, whatever you want to call your test statistic, divided by mu over standard deviation for this one test z-score. We're testing 95 against an average of 87.3 divided by standard deviation of 12. So we're going to get on top 2.7 and 5, 7.7 over 12. 7.7 over 12 is going to give me 0.64166, repeating 0.642. I'll round it off to 0.642. So that's our z-score. Our z-score is 0.642. Where is this on our normal distribution curve? So I've got my mean. We're testing above the mean, so we're testing up here. So let's see what's in the tail when we get this z-score of 0.642. And 0.642 is giving me 7389, 0.7389. So in the tail here, we have 0.2611. So we're asked for over 95, so that's the tail, so over 95. or greater than 95 is equal to 26.11%, or 0.2611. That was 15 marks in 2019 to add to the 10 from part 1, 25 out of 45. Nice easy giveaway marks and statistics in the Leaving Cert. Next, the magazine found the average speed of this sample was lower than the previous established average speed. Find the average speeds in cars in this sample. Correct to 1 dp. And I'm skipping a part A. Part 3 is actually this one. The driver of a car was told 70% of all speeds were recorded were higher than his speed. Find the speed at which the driver was recorded and give your answer correct to the nearest whole number. Okay, quick sketch to help us. Where's this driver on this distribution? If the average is here, 70% were higher, so he's over here in this bottom 30% here. So we need to get a z-score that represents, because we always go right to left. Here's my average. We need a z-score where the 30% is in here. So we want a z-score to represent 70%, or we go to find 0.70, or as close to that as we can get. Now you probably can just take in the Leaving Cert the nearest one to it, but 0.52 is 6985, and 0.53 is 7019. A jump of 15 and 19, so it's pretty much the midpoint. So 0.525 I'll go for here for my z-score. So some test statistic minus the average of 87.3 divided by the standard deviation, which was 12, is equal to this z-score that's representing 70%, which is 0.525, or in this case it's minus 0.525 because it's below. So we get our test statistic is equal to 12 by minus 0.525 is minus 6.3 plus the 87.3 is going to give me my score to be 81 exactly. And it's, what are we doing over here? Speeds 81 kilometers an hour will be this driver. He's below the average. A road safety program is carried out in the area using poster signs and radio slots. After the program, the Motoring magazine recorded speeds of 100 passing cars. The magazine carried out a hypothesis test at the 5% level to determine whether the average speed has changed, and the p-value was 0.024. Now a p-value is both tails added together. So if both tails added together is 0.024 divided by 2 is equal to 0.012. So 0.012. So that's what's in here. 0.012. What would I have to add to that to get to 1? 0.988. So if we go to the z-score table for 0.988, it's quite a high number. 9878, we get closest to is 2.25. Z-score 2.25 is my z-score. So 2.25 is greater than 1.96. Therefore, reject the hypothesis that the average was, and we didn't write it out. We were asked the hypothesis test, so now we go back and we say H0, the average is 87.3. Is that what we were testing? The average speed has changed, so H0 is 87.3. H1, you could say average speed has changed, mu not equal to 87.3. And we have evidence here to suggest that we're going to reject H0 because this p-value, or the z-score representing this p-value, is greater than 1.96. We could just take the 0.024 as well. 0.024 is less than 0.05, which is what it needs to be. I think rather than just doing that and writing that down, understanding where it is on the normal distribution curve with the average being in the middle gives you an idea. Is it minus 1.96 or plus 1.96? Has to be inside this range of values here. So we can say it's in the critical region is another thing we could say, critical region. So reject. So loads of different ways to do this type of question. The magazine found that the sample was lower than the previously established average speed. The magazine found the average speed of this sample was lower than the previous. Find the average speeds of cars in this sample. So let's look at this sample here. We've already done some of the work for this question. So in the previous part, the sample of they took 100 passing cars and they got this p-value, and we found the z-score for this p-value. And now we're told that this is below, so it's in the negative part. So this z-score must have been a negative. So negative 2.25 would be my z-score for the previous sample. We don't know what x is. That's what we're trying to find out. Find the average speeds, the test statistic that gave us a value that this sample was lower than the previous one. We're testing it against 87.3. The sample size was 100 and the previous standard deviation was 12, wasn't it? 12 down the bottom there, 12 over root 100. So x bar minus 87.3 over 12 divided by the square root of 10, 12 divided by 10, 1.2 is equal to negative 2.25. So x bar is equal to minus 2.7 plus 87.3. So x bar, the average speed must be 84.6 kilometers an hour.